Good morning, everybody. This is the big one, the review sheet. I can prepare for my modeling exponential functions test by knowing my formulas and practicing. If you don't know your formulas and when to use them, you are in trouble, my friends. I'm not going to play this song now, but listen to that song. I know it's a long song, but it has everything you need and when to use it. So that will help you memorize everything. Let's start with number 3 here. I want to find the growth or decay rate. In order to do that, I need just t in the exponent. So whatever I have with t, in this case 1/2 is with t, I have to absorb into the exponent. So it becomes a equals 9200, 1.985 to the 1/2 to the t. I want just t in the exponent, whatever's with it, I absorb into the parentheses. So now I'm going to just go and I'm going to type in 9200, 1.98, nope, just 1.985 to the power of 1/2. I get 1.4089. 1.4089. So now this is 1 plus the rate. So if I take this 1.4089 and I drop the 1, that's the rate at the decimal. To make it into a percent, I move the decimal 2 places over. I'm not sure exactly what I asked for. As far as rounding, I think I guess the nearest tenth of a percent, 40.9%. So if you want to know what the rate is, I need just t in the exponent. I absorb whatever is in the exponent into the parentheses. I type that in, and then from there, that's 1 plus or minus the rate. I drop the 1, and I make it into a percent by moving the decimal 2 places over. It's giving me an equation for the yearly rate. I want the monthly growth rate. I'm converting rates. Converting rates, raise 1 over n. I take what's inside the parentheses and I raise it to the 1 over n power. I want the monthly growth rate, so n is 12. I go to my calculator, I type in 1.025 to the power of 1 over 12, 1.00206, 1.00206. This is the monthly rate. So that's gone, that's gone. Now, you need to pay close attention to what the variable represents. The variable is t. T represents years. How many times per year do I get the monthly rate? 12. I get the monthly rate 12 times per year. If t represented months, then it would be 3,500, 1.00206. Let's call it m to the power of m. I get the monthly rate 12 times per year. I get the monthly rate 1 time per month. So either one is fair game for your exam. So you have to pay very close attention to what the variable represents. This is a complicated lesson. So if you're like, what's going on here? I would watch this actual video, the actual lesson where I go over it in more detail. But for converting rates, I take what's inside the parentheses. I raise it to the 1 over n power. That gives me the monthly rate or the weekly rate, whatever it's asking for. Once I have that, I get the monthly rate 12 times per year. So 12 goes in the exponent with the t for years. If the variable was months, you would get it 1 time per month. Which brings us to interpreting exponential models. When I see this, I need to know that this is initial parentheses 1 plus or minus the rate to the power of time. So 3,600 is my initial. This is more than 1, so I'm adding 0.025, which is 2.5%. So again, just by seeing this model, I know that the initial is 3,600. I know it's increasing because it's more than 1. And since I'm adding 0.025, I know that's 2.5%, which is false. The initial investment was 3,600, correct. The initial or principal is what's in front of the parentheses. The annual interest rate is 2.5%. Yes. Since I'm adding 0.025, that's 2.5%. The value after 5 years is 4,073.07. Well, let's substitute 5 in for t and see what I get. So I'm going to do 3,600, 1.025 to the power of 5. I have 3,600, 1.025 to the power of 5. I've got 4,073.07. So that one looks true. It will take 12 years for the value of the account to double. Well, let's substitute 12 in. Let's go 3,600, 1.025 to the power of 12. 3,600, 1.025 to the power of 12. 4841. Did it double? Well, if I'm starting with 3,600, doubling would be 7,200. Not even close. Not correct. That one's false. So A, you need to understand that what's in front is your initial or starting amount. What's inside is 1 plus or minus the rate, and you need to be able to pull whatever the rate is from that. And then if it's talking about the value after time passes, you substitute into the equation. You'll see one of those. Which brings us to the bulk of our unit, which is our formulas. If you see the word compounding, we use our N formula, unless it says continuously, in which case we use PERT. For half-life, we raise to the T over H. At a regular time, meaning it's increasing by 1% every 3.4 years or 2 days, not every one, every a regular amount of time. We also have T over H, but I have my regular 1 plus or minus the rate inside. If I don't see compounding, if I don't see continuously, if I don't see half-life, if I don't see a regular time, then we use our original OG formula, going back to Algebra 1, which is A equals P 1 plus or minus R to the power of T. So the first battle is knowing the formulas. If you don't have this memorized, you're done. Don't even bother showing up. You're done. If you do not know these formulas and when to use them, you are done. And also, regents-wise, this is a huge chunk of points on the regents. If you don't know these formulas, again, you really can't do any of this. You don't have a chance, so make sure you know your formulas. A bank account opened up 3 years ago with an initial balance of 12,000, now has a balance of 12,824. So I'm looking for the words compounding, continuously, half-life, or some irregular time. I don't see any of those things. Therefore, I'm using my original, A equals P 1 plus or minus R to the power of T. List your variables, A equals P equals R equals T equals. A bank account opened up 3 years ago, that's T, with an initial balance of 12,000. Initial is P. Now has a balance of 12,824. The after amount, after time passes, is now 12,824. P is the initial or starting amount. A is the amount you have after time passes. Find the rate. Okay, so I'm going to substitute my values in. 12,824. It's growth, so that means plus 1 plus R to the power of 3. Oops, I messed something up there. A equals 12,000, 1 plus R to the power of 3. Now I have to solve this equation. I isolate, I divide both sides by 12,000. I have 12,824 divided by 12,000. I've got 1.068 ... equals 1 plus r to the power of 3. I want to get rid of the power of 3. To get rid of the power, when it's a constant, a number, I root it. I take the cubed root of both sides. So I'm going to go alpha window 6 for the root, cubed root, and I'm going to copy and paste this. 1.022 dot 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 1.022 dot 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 equals 1 plus r. Now I get r by itself. I subtract 1, 0.022 equals r. It wants the answer to the nearest tenth of a percent. So now I multiply it by 100 or move the decimal over 2 places. Let's just get one more digit there, 1.0223. So that's going to be 2.2%. So if you're finding the rate, you're going to have to root it once you isolate the 1 plus r. So you'll see one of those. Number 11. Now, normally I go over like one of each, but you're responsible for all these formulas, so I'm going to go over each of these formulas. I'm looking for keywords, I'm looking for compounding, I'm looking for continuously, I'm looking for half-life, I'm looking for irregular time. Joe just opened a bank account with $5,000 with an initial balance with interest compounded. Boom, there it is. Does it say continuously? No. Compounded, not continuously, and formula. A equals P1 plus R over N to the power NT, compounding, PERT for continuous. I list my variables. A $5,000 initial balance, that's P. Compounded quarterly. N is the number of times it's compounded per year. Quarterly is 4. At a rate of 2.8%. Don't forget to make that into a decimal, 0.028. Write an equation for B of T. That's one thing I'm trying to train you to do, is write an equation first, the balance of the account after T years. End of question. Nothing after that period applies at this point. I write an equation with 2 variables. B of T equals 5,000, 1 plus 0.028 over 4 to the 4t. I like you to type what's inside the parentheses into the calculator, because that will make the algebra easier generally in the next step. So 1 plus 0.028 over 4 is 1.007. 1.007. That's the answer to the first question. Again, write an equation with 2 variables. That's the answer to the first question. Now, using your equation, how long will it take for his money to double? And you're definitely responsible for this whole doubling, tripling thing. If his money is doubling, that means that his balance, B of T, will be 2 times the initial amount, which was 5,000, which means B of T is 10,000. If it's doubling, you're multiplying the initial by 2. If it's tripling, you're multiplying the original by 3. So I'm going to replace B of T with 10,000 equals 5,000, 1.007 to the 4t. And now I'm going to solve the equation. 2 equals 1.007 to the 4t. Now that I'm isolated, I do log of both sides, log of the left, log of the right. So I have log 2 equals, the exponent comes to the front, 4t log 1.007. One step from the end, divide by 4 log 1.007. Those cancel. I have t equals alpha x log 2 over, 4 log 1.007 to the nearest something, to the nearest tenth of a year. That is 24.8. your other option, if you can't do the algebra, which really shouldn't be the issue because the algebra is really not bad here, but I could always do y1 equals 10,000. I can do y2 equals 5,000, 1.007 to the 4t. I can go to my calculator. I can go to y equals. I can type in 10,000. I can type in 5,000, 1.007 to the power of 4x. I can't type in t, I type in x. Since my y1 is 10,000, I'd have to make my window above 10,000. Let's make it 15,000. Graph. I need to see more of the right, so I'm going to either adjust my x max or I can zoom out. I'm going 50. There's my intersection, second trace, option 5, enter, 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 x coordinate, x coordinate, x coordinate, and I come up with 24.8. You may or may not get full credit for that, depending on if it says to do it algebraically. That's not my go-to, but I want you to know all the different options you have. Again, to solve any equation, you could always use your y1 and y2 intersect, and this is the work you would need to show if you're doing that. All right, let's take a look at the next one. Again, I'm looking for keywords. I'm looking for compounding, continuously, half-life, irregular time. The half-life, boom, there it is. Half-life, I write down my half-life formula. Half-life raised T over H. A equals P equals T equals H equals. The half-life is 12.4. That is H. It says the half-life is 12.4. H is the half-life, or the time it takes for the percent to be applied. P of T is A. 300 sample, that's P. That's your initial amount. T minutes. Substitute in P of T equals 300, 1/2 to the T over 12.4. There's nothing to combine. That's your equation. Follow-up question. How much will remain after 30 minutes? 30 minutes. What variable is minutes? Well, little t is time. So I'm going to replace little t with 30. Now, since there's no variable to solve for on the right-hand side, I don't have to do algebra. I can just type in 300 1/2 to the power of 30 over 12.4. Oops. 30 over 12.4. It says to round to the nearest milligram. That's 0 decimal places. That is 56. So if it's asking for A or whatever version of A, you don't need to do algebra. You just pop it in. You have the variable by itself already, and you can just type it into the calculator. I'm not going to do the rest of these problems. I'm just going to set them up and help you determine which formula you're using. I'm looking for keywords, continuously, per for continuous. 14, every 5 days, the loan will accumulate 2.5% interest. Every 5 days, that is irregular time. It's not every day, it's not every one of the unit, it's every some irregular amount of time. So I use my irregular time. 1 plus or minus the rate for the T over H. Where H is the time it takes for the percent to be applied, H would be 5. And this brings us to our final type of question. Again, this is not one of our formulas. A lot of words. I want to find my keyword or phrase. There it is. Exponential regression equation, expreg. So to do exponential regression, it's very simple. I go to my calculator. I go stat edit. I type in the data. If I have something in there already, I tab up so that the L1, L2 is highlighted and hit clear enter. My X is 0, 0.5, 1, 2, 3, 4, 6. My L2 or my Y's, 4, 10, 15, 60, 260, 11, 30, 16, 380. Enter. Oops, I missed a number there. So I always want to, when you type something in, just look back and make sure that it looks correct. Stat calc for xreg because it wants an exponential regression, which is what you will see in this course. Option 0, enter all the way through. Write the entire window. We talked about this to show your work. If you make a mistake, write the entire window. So I've got y equals a times b to the power of x. I have a equals, I have b equals 4.1679, 83971. B, I've got 3.9806, 19454. Make sure you write an equation first, just like before. The first question ends right here. Nothing past that matters. This 100 means nothing right now. Right now, the question ends right here, to the nearest thousandth. That's 3 decimal places, so we round each of them to the nearest thousandth. So A would be 4.168. and B would be 3.981. So now I substitute these values into the formula that they're giving you. Y equals 4.168, 3.981 to the power of x. The only thing to be careful of, if it tells you to use a specific variable, does it tell you to use a specific variable? Sorry, that noise, I just had to kill something. No, it just says to write exponential regression equation. Now, a follow-up question. The researcher knows that people are likely to suffer from foodborne illness if the number of spores exceeds 100. Number of spores, 100. Number of spores, 100. Number of spores, is that the X or the Y? Number of spores is the Y. This is your Y value. So I'm going to substitute 100 in for y. So it's 100 equals 4.168, 3.981 to the power of x. Since x is in the exponent, I have to solve the exponential equation. Just like we did before, I isolate first. 100 divided by 4.168. 23 ... equals 3.981 to the power of x. Log of both sides. Log of both sides. I have log 23 ... equals x log 3.981. I'm one step from the end. Divide by log 3.981. Divided by log 3.981. X equals, I'm going to type that into the calculator, alpha x log, copy and paste, over log 3.981. Now, earlier in the problem, it said to round to the nearest thousandth, but this is a different question. This question says round to the nearest hundredth of an hour. That's 2 decimal places. That is 2.30. And remember, if you can't or whatever, if the algebra is not happening, if you get lost, you make a mistake, you could always do your y1, y2 intersects. Y equals 100. Y2 is 4.168. 3.981 to the power of x. I'm going to make my window, my y above 100. I'm going to go back to that 10. I'm going to go back to, I don't know, 150. Yep, I see the intersection. Second trace, intersect, enter, enter, enter. X equals 2.30. And if you're doing that, again, the work you need to show is y1, y2 intersect. That's it. That's what you need to know. If you don't know your formulas, you are toast. So make sure you know your formulas and practice, and goodbye.